Hi all, and welcome back to the shed. So basically this time around, one of the followers on the Facebook page for eco-worthy VIP users, or whatever it's called, I don't know, they had a question, and I am one of the moderators slash experts for that page, is what they call me, experts. I think I'm the only one actually, but anywho, somebody had a question about wiring up a eco-worthy Hall sensor battery monitor, and I actually happen to have one. I used it for a while. The recalibration of it was kind of driving me crazy. I only had to do it once. And then I went ahead and moved on to a shunt, but that's besides the fact. So I still have the sensor, and he had a question on how to wire it and calibrate it. So I'm going to go ahead and take care of that now. We're going to start with discharging the batteries, which is something I told him that he had to do. With the Hall sensor, you actually have to discharge the batteries down to 10.1 volts with your lithium iron phosphate batteries. That's pretty typical for most of them with the BMS and all that. And then you calibrate it to 0, and then you charge it all the way up, which I'll use a house charger for that. I actually prefer to use the AC to DC house charger for that, because it's just a constant power supply. It's easy for the Hall sensor and the monitor to read. And then once it hits 100%, you either leave it on there, and it'll calibrate to 100% after a while, or you calibrate it to 0. I don't remember off the top of my head, but we'll cover that in the video. So right now what we're going to work on is draining the batteries, and I actually have a load tester is what I'm going to use. I meant to get this going this morning, but I get busy. That's the way it is. So right now you can see I've got a load sensor here, and it's hooked up. I've got I've got power to it that runs up to here. Of course, we don't have it turned on yet. And then it's got a lead out for the hot, and then a lead out for the negative. And I've got them hooked up, of course, you know, crossways, as I have all of these batteries connected in parallel. These are basically your eco-worthy batteries. These are your 30 amp hour 12.8 volt eco-worthy batteries. I don't have a clear shot of the front or to show that to you, but heck, that ought to work just fine. Get in there, and maybe you can read it, maybe you can't. I'll try to do a different segment in the video that kind of describes the battery, but they're good little batteries in my opinion. I got nothing to complain about. I haven't used them a whole bunch. I bought them for another purpose, and then life goes sideways sometimes. So let's go ahead and let's get the load tester here kind of up and going, and we'll start drawing out a load, so that way we can get these batteries drained. That'll be the first segment of the video. Now, in saying all that, I want to, anyways, like I was saying, you don't have to use, like, you know, a load tester or something like that, or a gizmo like this, which is the Cooler Master. It is something I bought off of Amazon, and I'll put a link in Amazon for that, or link down below in the description about that, an Amazon link. And basically you can, like I said before, you can just use your, you know, DC to AC inverter with a light bulb, like a 100-watt light bulb, and just run it. It's gonna work out for you. You know, I like to, you know, when I'm draining something, I like to do a little bit of math and figure out where everything's at, so I'm not constantly coming back to look at it. Because if you go below 10.1 volts, the BMS is going to shut off. That's all. We'll come back to that. So let's take a quick look at where we're at now for power. And it looks like we're at 13.1. 13.11, which is pretty good. And then what we'll do, now these instructions are kind of funny, but they work. Okay, it's like, you know, so we'll go ahead and just turn this on. Everything's powering up here. You can see that the fan starts spinning. what we're going to do is, I've got it set up 12.9 volts. That works for me. I'm going to crank this up to whoops, not going to let me do that. See, there's a limit to it. When it gets up to so much, it's like, no, we're done. Okay, so let's let it run at like 11 amps for right now. It's saying 12.7 volts. Let's check that too. Let's double check with the old voltmeter here. Yeah, voltmeter says a little bit more, 12.9, but you can see where it lost a little juice just by cranking that bad boy up. So we're going to let this run for a while at 11 amps, and we'll come back and check it in a while until we get down to our 10.1 volts, and then we'll go ahead and get everything wired up for the Hall sensor monitor, battery monitor from EcoWorthy, okay? Okay, so I've got the battery charged down to what the BMS would allow me. Now, I know that EcoWorthy on the batteries, they say that it will discharge down to 10 volts before it clicks to 0, which is 10.1 would technically be 0. But honestly, and I did this with another battery also, it only goes to about 11 volts or so, and then the BMS deactivates, which is fine. All that voltage at the end is kind of nothing really. It's very rapidly discharged. So you can see, as I've got like, let's spin that around, I've got my lead hooked up, and I've got on there 11.47 volts. That's where I had to jump start the BMS again to get it going. Now you can see up here on the, this is the EcoWorthy monitor. Oh boy, I don't know if you guys can see that or not. Might be better off to do it this way. See, it says 100%, 393 amp hours, which is not correct. That's from the old setup that I had when I was still using that particular one. So what we're going to do, first we'll go over some of the wires here. So you see the red wire goes back to here on the dual plug-in one with the red and the black. Okay, not the quadruple pin, but the dual pin. So that one comes all the way down through, and it feeds through the hall pass monitor and goes down and attaches to the negative. Also the negative, I have, this is just a negative lug here, right? It goes through the hall pass monitor also, or hall pass sender, hall monitor, like we're back in school. Okay, and then I've got, right now I don't have a load on it. I might put a load on it later for fun. But essentially I've got the positive end of 20 amp EcoWorthy battery charger here, and then the negative end of the battery charger hooked to the negative terminal, if you want to call it that. And then we have the black wire that is again off of the dual pin plug-in back there, not the quadruple. The quadruple just goes from here and it plugs in over to here at the hall sensor monitor. Okay, so this thin black wire comes all the way around to the negative terminal. All points on the negative meet here, all points on the positive more or less meet up over there. So the question being was how to get this calibrated. So we're going to calibrate this to 0. If you just hold down this button for 3 seconds, the bottom arrow button, it will reset everything to 0. Let's do that now. Everything's at 0. I'm going to turn on the old charger over here. It could be your solar controller, whatever you're using. I always recommend a charger for the first time out, just to have an accurate setting. And we get it going. You can see that amperage is climbing up. We're charging at 20 volts. And, you know, we'll circle, or 20 amps, sorry. And we'll circle back in a while. This is a 30 amp hour battery. It shouldn't take much more than an hour and a half or so to get her tuned up and charged up. And we'll come up and then we'll either it'll say on the battery monitor itself that it is at 100%, or we'll click the arrow button up for 3 seconds and that'll make it 100%. And then this thing should be golden to work on its own, and we'll put a load on it and all that stuff at that point. Okay, we'll tune back in. Okay, so we're back out here. I got sidetracked with some other things to do and came back, and this little battery was fully charged. Didn't take long. Just to take a closer look at it here. Yeah, I try to get the reflection away from that. So it automatically, just after so many minutes or whatever, it just said, okay, we're at 100%, we're fully charged. Saying 29 amp hours. These batteries are supposed to be 30 amp hours. And like I said in the beginning of the video, they don't discharge all the way, so we're losing an amp hour there somewhere, but I'm not willing to sweat it. They're good little batteries. So anywho, just a quick recap on this. We got to make sure that the positive flow is going the correct direction, and it travels along with the little red wire. So the red wire clamps onto the positive terminal, goes up and through the sensor, which is, of course, the sensor is plugged in to the back of this here. Now, just to get a closer look, this is all for the EcoWorthy battery monitor. It is a ECO-BM100V. And all in all, it's a pretty good little unit. I mean, I had to recalibrate it at one point. I ended up going with the Smartshunt so that way I could read it, remotely and stuff like that. So this is kind of a representation of, how this works and how it's wired together. Remember, the negative lead has got to go all the way to the negative terminal. Positive lead, it just kind of feeds on through, and it goes through and it hooks up to the positive side of the battery. Okay, so this negative goes to the negative terminal. It's just we have a common point here, and it travels back to here. So technically, both of these leads have to go to positive and negative in one shape or form or another. So I hope that answers your question about how to get this wire together. And if you have any more questions, just go ahead and reply in the comments, and we'll get it dialed in for you. And appreciate you watching my channel. Anybody else finds this useful, let me know. And there's a lot more EcoWorthy stuff coming up, and other brands also, as we kind of get more into depth than just reviews. There's going to be more tutorials on how to hook these things up, how to set the settings, really have good success with these controllers, and be safe when we're doing it so we don't start any fires or have accidents. Okay, thanks guys. Thanks for tuning in.